Hello, students. Today we are looking at angles of elevation and depression. This is basically, if we think about it, word problems based on the trig that we did in the last video that we had.
That sounds great. I'm so excited. I love the trig and the applications sound great.
And one of the things that we would totally have you do if we were in class is hold your arms straight out in front of you and tell you to elevate or to depress your arms, which means lift or push them down.
I don't think I've ever had students do that.
Oh, I do that all the time.
This is the point in the year when I jump in the window and I show the students that the windows were designed specifically for me because I fit exactly in the windows.
That is fair. I do not. I stand up and I hit my head pretty quickly.
It's because you're just like a scooch bit taller than me by 7 inches or something. I don't know.
But in terms of the idea of an angle of elevation is looking up from a horizontal, and depression is looking down from a horizontal, which we can see in this lovely picture that has a dog and an airplane. All right, so we've got some stuff and we're on the lighting crew, and we want these lights both on her. We're trying to figure out what angle each of these should be for this.
Do we need to put the 25 on the picture?
That would be helpful. I just had to scan the drawing with my eyes because I could not figure out what the height was, and I, for whatever reason, skipped over that in my brain as I was reading.
Second sentence, 25 feet above the stage. I was a little confused as you were saying what was going on. I was like, we need a piece of information that for some reason they didn't give us, but they put the 10 in the picture.
Yep. So we have 25 feet tall, and we're trying to get these lights and see what angle from the horizontal we should set these at. There's also a really cool thing that happens. I think this is probably a good time to talk about, where the angle of the light is going to be the angle based on this, but the ceiling is parallel to the floor. So the angle of depression for this light is going to be the same as the angle of elevation from the bottom of the triangle. And that's a really helpful thing to notice. The other really important thing is that we're not talking about that angle. That's where we often see mistakes, is we look at student work and see that they've found that angle instead of the actual angle of elevation depression. So it looks like we have sides of a triangle. It looks like we're trying to find this angle up here, which is the same as this angle down here.
So we could look at two different triangles is what you're saying. So I could look at like this triangle here, which will show up, or I could look at this triangle here.
You could, and they'd both be the same triangle.
Okay, I want to look at the yellow triangle.
Sounds good to me.
So I should label the sides. So this is the hypotenuse. This is the opposite. And this is the adjacent.
All right, so I can see that we know the opposite and we know the adjacent based on this angle. Someday my circle will finish on that angle. There it is. And if we're thinking,
I moved the picture so we actually had room to do work.
I know, I started writing SOHCAHTOA in white, and then I had white
background. I saw that. I regretted my movement as soon as I did it, but it worked out. SOHCAHTOA.
Oof, there we go.
So we have the opposite and the adjacent, so we should definitely pick cosine, right?
I disagree with that statement.
I was just trying to mess with you.
Okay.
So we should pick tangent. So the tangent, we got to put the angle in there. So the tangent of x is opposite over adjacent, 10 over 25. Sorry, 25 over 10.
I like that you wrote the right thing, but started saying the backwards thing.
I have magic in my brain. And we got to do that inverse tangent idea. So inverse tangent of 25 over 10. And hopefully Mr. Carlson is getting out his calculator right now and figuring out what, oh, look at that. It's like magic.
and we get 68.1985 degrees. I'd like us to notice that both of these triangles are the same because they're both 10 feet in the bottom, 25 feet going up. So we are okay with that. Rounding to the nearest degree, I don't really care about rounding. I will never
I do.
mark you off if you
68
round wrong.
degrees. Now it says, describe how each angle changes if you set the lamps for her to stand a few feet closer to the tree.
Ooh, that could be a little bit interesting.
So they're saying she moves this away to the right.
Mm-hmm.
So the angle for the A lamp would be less, and the angle for the B lamp would be more.
Because the angle for the A lamp would then be like this part. And for the B lamp would have to go a lot closer down.
I like it.
I even tried to do those to match the colors of the lamps-ish.
As best we could,
As best we could.
using the colors we're given.
Cool.
So now we just have words about angle of elevation, angle of depression. Y'all can pause the video and read those words. Basically, elevation goes up, depression goes down. They are measured from the horizontal, and that's really important. That's what Mr. Carlson was talking about. We don't talk about the angle in there. We just don't. It's not part of our discussion in a lot of these questions. Someday you may be asked that, like how to get to that question, that piece, but in terms of the calculations, generally, we're not going to discuss that.
And the other piece, again, this is really important, is that since the horizon is parallel to any other horizontal line, these are alternate interior angles and are therefore always going to be congruent. So you can find one if it's easier to draw the picture that way, and that will give you the same value for the other one.
I like it. Connecting old content to new. Ooh. So we've got, what is the description of the angle as it relates to the situation shown? Angle.
Is that a bird?
I think so.
Cool.
Because it's a lot smaller than the person. Although, no, it's probably roughly the same size as the person.
That's a really big bird.
We'll call it the condor. So the condor is flying in the air there. So I think the angle 1, I think they want us to say that's an angle of depression.
And that's because the condor is looking down from the horizontal to see the human.
And then angle 4 is an angle of elevation.
Because the mountain is looking up from the horizontal to look at the person.
Mountains don't look up.
This one does.
Okay. Use the what is the description of the angle as it relates to the situation shown? So angle 2. Is angle 2 an angle of elevation also?
Well, this person is looking at the mountain and then has to look up to the condor.
Ooh.
So I would say that's an angle of elevation.
And then is it an angle of depression number 3?
Well, if they're looking at the horizontal and then depress their gaze to look at the base of the mountain, that would make sense to me.
You say depress their gaze?
Well, that's what it means, to lower your gaze.
Yes, I agree. I don't think the students have ever said that in their lives. All right, suppose you stand 53 feet from a wind farm turbine. Those things are terrifying up close. Your angle of elevation to the hub of
there we go.
The turbine is 56.5 degrees.
It wouldn't go away.
Your eye level is 5.5 feet above the ground. Is that because the person's roughly 5.5 feet tall?
Yeah, this diagram is terribly not to scale.
Yeah, because turbines are huge.
And this would be like 30 feet off the ground.
Yeah. Approximately how tall is the turbine from the ground to its hub? So we want to find this whole distance right there. I drew for me. We know this distance so far is 5.5 feet. That's where the person's eyeballs are.
So
if we find X, we're in good shape.
Yeah, because then we can take the triangle stuff and add it to the 5.5. That's just kind of like an after step. Um,
All right, so we label the sides. So this is the angle we're dealing with. We told you to circle it, so good idea. This is the hypotenuse. That is the opposite. And this is the adjacent. So we have the opposite and adjacent. I don't know which one to pick because Mr. Carlson never told me what my mnemonic device was. So katoa. So we got the opposite and adjacent. So we're going to pick tangent. So the tangent into the tangent, we got to put the angle. So 56.5 degrees. And that's going to equal the opposite over the adjacent. Is that okay set up, Mr. Carlson?
that looks pretty good to me. And I feel like there's a
Beautiful.
pretty good choice to do next to get the x by itself, because it's just dividing by the 53. So if we multiply both sides by the 53, we end up getting this expression, which if you use a calculator comes out to be 80.07.
Oh, nice.
And we're in feet. It's equal to x. Are we done?
Definitely no. Wait, we're not. We found out what x was. We want to figure out what the green thing is. So we have to add 5.5 to that. So it's going to be 85.57 feet tall from the ground. That's a
from
misspelling.
the ground to the hub.
Yes.
Okay.
So students, I want you to look up wind turbines and email us and tell us if that's an accurate measurement. I have no idea. I don't know how tall wind turbines are.
Yeah, I don't either. It would also be interesting for you to go and experience how tall they are by going and visiting any of the various wind turbines we have in the area. I know
Don't get too close because they're scary.
Yeah, there are a few in Gloucester. I know that there are a few along like Plum Island and Newberry area too.
Nice.
All right.
You sight a rock climber on a cliff. Uh-oh. I hope the person's not in danger. At a 32-degree angle, your eye level is 6 feet above the ground. So we have a 6 feet there. You are 1,000 feet from the base of the cliff. What is the approximate height of the rock climber from the ground? So we want to find, again, this whole piece. So we need to find, I'll call it Z, and then we're going to add 6 to that.
I feel like this is a really similar problem to one that we just did.
This is basically the exact same question.
Do we often see that these are really similar problems to each other?
Yeah. So we're going to do the tangent of 32. And tangent's going to be kind of your jam with a lot of these because often we don't care as much about the hypotenuse. Is that accurate, Mr. Carlson?
Yeah, there are a few times that we do. Usually they deal with things that are really useful to students, like talking about guy wires.
That's what I was thinking, guy lines.
Which are the wires that tie like the top of a telephone pole to something that it supports to keep it from tipping over.
So I don't think we need to belabor the point here. We wrote the tangent of 32 is opposite over adjacent, the Z over 1,000 feet. I didn't write opposite adjacent hypotenuse on the triangle, but it's the same problem as last time. So I didn't think we needed to. Multiply by 1,000 and you're going to get 624.86 feet. But again, you got to add 6 to that. So 620, nope, 30, forgot how to add. 30.86 feet is how high the rock climber is off the ground. Which if that were me, I would be a little terrified because I'm scared of heights.
Yeah, it's pretty high up.
Unless I was like tethered in, I'm okay.
All right. So now we have a little bit less information in the picture, and we have some extra numbers in there like runway 17 to kind of distract us. And it says that we're starting at a height of 2714. And I'm going to do something interesting. Oh, I wonder if that was a plane in the other picture. I'm going to put the 2714 here because that's an easier triangle for me to draw. Mr. Butterworth, just go look and see if it was actually a plane.
Yeah, it looks like a bird because it's got like the curved wings.
And then we know that the airport is 1,007 feet above sea level. Ooh. So we actually have some extra stuff here where this is 1,007 feet. And
that's right. There's a sticky note there that says, what is the distance from the ground to the airplane? We need that.
So the whole thing is 2714. And if I take 1007 from that, we end up getting 1707 as that height. And we want to know how far from the runway is the plane at the start of the approach. To me, that means this, the
I would agree.
hypotenuse. Sometimes we have really weird ways of saying things so that we can talk about just the horizontal part. But the distance from the runway to the plane is talking about the hypotenuse. That's the closest way we can get there. I'm also going to redraw my triangle because there's a lot of stuff going on there.
Is it fair to say, Mr. Carlson, the hardest part about this is not the trigonometry, it's the reading?
Yeah, I think that's a really fair part for this, especially with some of the way that we build problems and make them way more complicated than they need to be to try to make them interesting to do mathematically ends up being a little bit problematic. I'm also going to make use of what we had talked about earlier, that these angles are the same, and that's going to be 3 degrees.
That's that alternate interior angle idea.
Just because that was an easier triangle to draw, and often that will be the case.
Yep.
All right, so Butterworth is going to set this up. I will do the calculator stuff.
So I got that angle. This is the hypotenuse. I affectionately call it the hippopotamus. Pew! That's the opposite. And this is the adjacent. So we have we don't care about that. We got SOHCAHTOA. So we're going to deal with the sine. So the sine of a measly little 3 degrees is 1707 over x. Ooh, so this one's one of the spicier ones. So I'm going to multiply by x. And then I'm going to divide by the sine of 3. So I'm going to get 1707 over the sine of 3. And Mr. Carlson's, he's going to write it right now. I'm ready.
32,616.2
feet.
And that's in feet. So if I want this in miles, which to be honest, I don't care about.
But the question says so.
We're going to divide this by 5,280 and get this to be 6.177 miles, which they want to the nearest tenth, 6.2 miles. And by the time that they calculated this,
so if you're annoyed by the calculations, yes. But if you're annoyed by the calculations we just had to do, write to your nearest senator and say, can we switch to the metric system? That would be lovely. Now, there's a couple questions for you. For you, it says so. So we want you to try these. We are not going to do these. We are going to move the picture down so you can see all the question. And we want you to try these and then ask us questions if you have them. For you. I suggest drawing pictures, making note of things. If you are struggling with the drawing pictures, let us know and we can help support you.
I feel like this would be a great starter for class to do for this as well.
That sounds fun.